Let's talk about Web3.js. So what is it? What does it do? Why do we need it? So if you remember our diagram that we've been using in other videos, this is a diagram of the Ethereum network. These are the nodes on the network that all talk to one another. Each of these nodes, gets a copy of all the data on the blockchain, all the transactions, the public ledger. They talk to one another to achieve consensus on the state of the public ledger. And, people can connect to this network in order to use it, right? To send cryptocurrency, to use smart contracts, to deploy smart contracts, whatever they want to do, they can connect to this network and take full advantage of the power of the blockchain. And, if you remember in my previous videos, this boot camp, I talked about how in order to connect to the blockchain, you need to connect to a single Ethereum node, and that single Ethereum node is going to be your connection point to the blockchain. That's how you're going to access the entire network, is through one node. So you can, run a node on your own, or you can connect to one, remotely somewhere else that someone else hosts. Either way, you need a URL to the Ethereum node to talk to the entire blockchain, okay? So once you've got that URL, you could use the blockchain just by talking to smart contracts directly, or you could also just, you could send cryptocurrency yourself if you knew how to use Geth or something like that. But more than likely, you're going to be using the blockchain with some sort of user-facing client, some sort of application, some sort of, UI that allows you to, leverage the blockchain, whether it's a dApp or just some sort of wallet interface or something, right? And that interface needs to connect to the blockchain. So how does it do it? Well, there's a lot of different programming languages that your interface could be written in. Let's just take JavaScript, for example. You might have a JavaScript application that works like, MetaMask. It might be an Ethereum wallet client that shows your Ethereum balance and also allows you to send transactions and stuff like that, like we talked about during the wallet video. It's a client that, talks to the blockchain. So it's going to talk to a single Ethereum node on behalf of the entire network. But how does it actually, how do we connect our client to the node? Well, that's where Web3 comes into play. So if you look at this diagram, you see all these nodes. You see, here's what's going on inside the single Ethereum node. Here's your JavaScript application or your Java program or Python, whatever it is. I'm choosing JavaScript in this example because we're going to be programming with Web3.js. It talks to the Ethereum client with something called JSON RPC, right? Which is basically just like, just network calls to a node. And you can write all the JSON RPC calls yourself and, handle all the parameters and do that. Or you could use a library that abstracts all that away and does it for you under the hood in a language that you already understand. So Web3.js is basically going to give us a JavaScript way to interact with the Ethereum blockchain. It's going to allow us to write applications that are going to be blockchain applications. So they're going to connect to the blockchain and allow us to, interact with smart contracts, interact with the network, read information from the network, create transactions. Pretty much anything you can do on the blockchain, you're going to be able to do it with Web3.js. And we're going to rely on Web3.js heavily in the Capstone project, which is why I want to give you a crash course on Web3 in this video. So we're not going to cover everything Web3 can do in this video. We're going to kind of just give you an introduction to how it works and the syntax and stuff like that. And we're going to go really in depth on Web3 by example in the Capstone project. So here's the documentation to Web3.js. This is web3js.readthedocs.io. This is for version 1.0. And you can browse this if you wanted to get a more familiar understanding with Web3. It's really helpful when you're becoming a blockchain developer to, kind of look up all this stuff in here. You can see all the namespaces for Web3. We'll go through all this stuff, but this is definitely something you should know about. Okay, so I'm going to show you Web3 basically by example. And you don't necessarily have to follow along with the coding part of this if you don't want to. You're going to get plenty of exposure to Web3 in the Capstone project. But if you want to, I'm going to give you a quick overview of the dependencies required to follow along. Now, I'm not going to walk you through in setting up all these dependencies. I'm going to do that in a dedicated video in the Capstone section. But really high level, you need Node Package Manager, which comes with Node.js. You can see if you have Node installed by going to your terminal and typing node-v. Okay, you can install Node here by just following up the instructions. And also, you're going to need access to an Infura node. And you can get a URL by signing up. I'm going to show you my Infura node in this tutorial. And you can probably just use that one. It may be dead if a bunch of people use it from the boot camp. I don't know. So it's safer to just, register here and get your own. Again, I'm going to walk you through this step by step in the Capstone project. And the last thing would be the Ganache personal blockchain, which is we're going to use to just basically like send Ether around. And you can download that right here. All right, so if you want to install Web3 to follow along, you can install it with npm like this, npm install Web3. And I'm going to use Web3 1.0 version beta 46, and you can do that like this with the @ symbol. So that's how you install it. And I'm not going to complete that because I've already done it. So anyways, let's kind of just get started. I'm going to open up a new project in Sublime Text. This is actually part of a tutorial I did on my channel, but I'm going to walk you through this step by step here. So I'll put a link to this later in the video. So basically, Web3, like I said, talks to the blockchain over RPC, and we need access to an Infura node or any Ethereum node really to talk to the blockchain with Web3. You can do this in a console if you wanted to, but I'm going to do it in just a basic app.js file so that we don't have to keep like redoing stuff. So I'll say const web3 equals require web3. It's going to pull in from the node modules here that I've got saved in this project. And now I'm going to insert the RPC URL that I got from Infura. Like I said, you can probably just use this one, but I'm not going to make any promises. If a bunch of people get into the boot camp and start using this, it might get deprecated. But that is how you do it. So now I'm going to create a new Web3 connection like this. Okay, so that's going to say Web3 lowercase is going to be a new instance, new Web3 that we imported right here. And we're going to pass in the URL to the Ethereum node. Okay, that's what this URL is right here, all right? So now this right here is our connection to the blockchain. All right, so let's check this out. We'll run the script just to make sure everything imported properly. I'm just going to run this with Node. I'll say node app.js and see what happens. All right, so nothing broke, right? It was fine. We can actually console log just to make sure. Console log connected. Try it again. All right, we see connected. So now let's create some kind of smoke test just to make sure that this worked. What I'm going to do is actually log the latest block number, okay, like this. So Web3 has a namespace called ETH or ETH or ETH, whatever you want to call it. You can see it over here in the API reference. And this is like where all the methods live that are going to allow you to interact with the Ethereum network itself, okay? And there's a method inside here called getBlockNumber, which is going to get the block number of the latest block, and we're going to log it out of the console. So if you go to Etherscan, I'm going to go to Etherscan right here. You can see the latest block right here. So we should be logging this value to the console. And remember, if you go back into the boot camp, we talked about how the blockchain is made up of transactions that are grouped in bundles of records called blocks, which are chained together. Well, each block's got a number, and we're going to log the latest block number to the console like this. So we'll say node app.js. All right. So 749613. Yep, there you go. That was it. It just changed, but we saw it sync up in real time. So we are connected to the blockchain with Web3, and it is working properly. So that's the latest block number. All right, so let's do a couple more things. Let's get the balance of an account. I'll show you how to do that. So if I open my MetaMask account here, I'm going to actually just copy this address. So I'll copy it like this and put it in here. Let's say const address, my MetaMask address, and I want to get the balance of this, right? So if I go to MetaMask, you can see I've got almost 3 Ether inside of here, and I want to use Web3 to see what my balance is. So if we wanted to build an app like MetaMask, we would need to read balances of people's accounts, and we could do that with Web3. So I'll show you how to do that. We'll go to MetaMask, sorry, to this project, and say Web3. We'll use the ETH or ETH or ETH, whatever you want to say, namespace, and we'll say get balance. Okay, and I'm going to pass in the address. All right, now this is an asynchronous call, so you can handle that in a few ways. You could say, then, and handle it with promises, right? Or you could do the Web3 way for 1.0 and pass in a callback function. Would be like this. The first argument would be an error. Second would be the balance. And then what I'm going to do is actually format the balance. Let's say console log web3. Well, let's just do it this way. I'll format it in a second. So let's do this. See if you got any errors. All right. So this is a really big number, which looks kind of like what we saw in MetaMask. That's because this is the Wei value. So what is Wei? Well, Wei is a subdivision of Ether. It's kind of like a penny for Ethereum, a really small penny. You can see the subdivisions of Ether here at etherconverter.online. So Ether breaks down into Finny and micro Ether and nano Ether and I guess pico Ether. I'm not sure how you say that one actually. And Quay and Wei. So Wei is the smallest. It's 18 decimal places. And you'll see that standard a lot for Ethereum and other Ethereum-based tokens. And this is basically, that amount with 18 decimal places behind it. So we can format that. We can format the Wei and go to Ether like this. We can just say web3.utils. So this is a new namespace besides the ETH namespace. Say from Wei, and then say the balance, and we're going to say that we want Ether. Okay. All right, let me save that. Console log it. Run it again. All right, now that looks like the number we saw in MetaMask with the decimal in it. Okay, so that's how you read an account balance with Web3.js. Let's see what we can do next. Let's read some information from a smart contract, okay? Let's look up a smart contract on Etherscan. I've already got one pulled up here. This is the OMG token. We're going to talk more about tokens in the next section. But basically, just really quickly, Ethereum tokens, ERC20 tokens, are just smart contracts. And they have a lot of properties, which we'll cover in the dedicated video to tokens. And we're going to build a token in the Capstone project. So you're going to get all the details there. But just really quickly know that, you can read information about it. So let's just verify this token has a name and a symbol and stuff like that. So, basically tokens are named, they have symbols, so they can be identified on exchanges and stuff like that. So let's just kind of get some basic attributes about it. So if we were going to do that, we need a few pieces of information. We actually need the address for this token. It's a smart contract that's deployed to the network. We need the smart contract address. And we need the ABI, which is the abstract binary interface, which we're going to talk about more. Basically, those two pieces of information tell us where the token is and what it does. The address is where it is on the network, and the ABI is basically the description of how the token works. All right, so I can find the code to the OMG token here and click the contract address and see this code tab. All right, and this code tab shows us the Solidity source code, so you can trust the token. But also, here's the ABI. So this is basically a big JSON file, or JSON array, that tells us what the token does. Basically, it tells us all the functions and stuff like that, what their arguments are, what they return. So you can copy that. And also what you need is the contract address, which we clicked on to get here, and that's it right here. Here's the contract on the network, so copy that. And with these two pieces of information, we can actually create a JavaScript representation of the smart contract with Web3 to interact with it. And we're going to do that more in the capstone section, but I'll just show you the basics right now. So I'll paste in the OMG ABI like this. It's going to be a big, long JSON array. I've got it on one line here. And I'll also paste in the address, which is like this. All right. So now we can instantiate the contract with Web3 like this. We just say const contract equals new Web3 ETH. This is under the ETH namespace. Say contract and then ABI address. All right. So now we've got a new contract. We can console log that. Contract. Okay. All right. See that? Okay. So I had an issue here. Let's see. Address has already been declared. So let's change that. This was my address from reading the balance. My fault. Take that out. All right. So we can see the contract worked. No errors. All right. So far, so good. Now let's actually get some information about the token. Let's get the name, right? So we can see the contract name is OMG token. And let's see here. We can see that this has a function called name, right? String public name, OMG token. So let's call the name function. Basically, this is given to us by Solidity. So Solidity, whenever you create a state variable that has public next to it, it's basically going to give you a reader function for free that exposes a function called name with this variable that corresponds to this variable. So I can get the function name like this, say contract methods. Okay, so this is going to be the smart contract that we cached right here, methods, and I can say name. All right, and then when we do that, it's not enough to just say call the name function. All right, you actually have to say call. All right, with Web3, and then pass in a callback function, which is going to be the error, just like we saw earlier, or the result. And we can console log the result. All right, now let's click our script. All right, it worked. So we see the name OMG token was returned here. We're actually talking to a real live smart contract on the Ethereum main network right here with this URL. We're returning the same information you're seeing on Etherscan right in your console. All right, so that's how you read information from the smart contract. We could go on and on about how to get the name, the symbol, total supply, but basically, that's just a quick and dirty reference on how to read smart contract functions. Like I said, we're going to do a lot of this in the capstone section. I just want to give you an introduction to it here. This is a call method, which basically reads data from the blockchain. There also are send methods with Web3, which are different. So like if I go to transaction, I can show you how that works. Or if I go to this part of Web3, you can see an example. So a call method, we'll call a constant method, which basically just reads data from the blockchain. It doesn't send any transactions, right? So it's important to distinguish between that and a send method right here. This will create a transaction on the blockchain, and this can alter the smart contract state. So it's important to create distinctions. So with call methods, we had to say call after the function call, and with send methods, we have to say send after the function call. And you're going to see that in the Capstone project a lot. But I want to give you an introduction to it here before you get to it ahead of time. All right, next let's talk about how to send Ether on the network with Web3. This is basically just saying, I want to send you, 1 Ether, 1 unit of Ethereum cryptocurrency or something like that between 2 accounts. And I'm going to show you how to do that as sort of a basic, operation in Web3.js, because it's kind of a fundamental thing to know how to do. So we can do that like this. I'm gonna not do this on the main Ethereum network. I don't want to potentially show you all how to lose real money. So we're going to connect to Ganache, and I can just open Ganache. All right. So here is our personal blockchain. Like I said, we're gonna set up Ganache step by step in the Capstone section, but we can connect to Ganache like this. So just copy the URL. So basically, this is our new Ethereum node. Instead of connecting to that Infura node that I showed you before, we're going to connect to our local blockchain. All right, like this. So this just stands for localhost, and we're going to do port 7545. And we can, get a smoke test that was working, and we can basically just get the block number, make sure it worked, just like the last section. Try this again. All right, so block number is 0, which is fine, because it's Ganache. We haven't mined any blocks yet. We're at the Genesis block. Okay, so let's see. Let's just send some ether from one account to another. First of all, we need an account, const account 1, and then we'll say const account 2. So we'll send ether from this account to this account, and we'll just copy the accounts from Ganache like this: account 1 and account 2. All right, so we can just send ether. We're just going to create a basic transaction that has some parameters, like who the transaction is being sent from, who it's being sent to, and the amount of value, which is going to be, the amount of cryptocurrency that's getting sent with the transaction. Okay, so we can do that like this. We just say Web3 ETH send transaction. And let's go look at the documentation just to see how it works. So it accepts a transaction object and a callback. So the transaction object, we can build it like this. We could say from, this will be account 1, to account 2. All right, let's look what else we need. The value, this is going to be the amount of ether that we're going to send. So we'll say value. We can say, and this needs to be expressed in way, right? Value. Okay, yeah, in way right here. Transaction in way. So we can say Web3 utils a two-way. We can say 1 ether. And actually, I think I need to do this as a string. So we'll do it like this. All right, so let's run that. Say, all right, so let's see. I didn't log out to the console. Let's see if it worked. Yep, it worked. So if you see address 1, the balance went down, and we can see the balance went up here. So we can additionally pass in a callback function. Say, let's see what the arguments are. Callback function optional returns an error object as the first parameter and the result as the second. So say error result. Just pass this in. Result. All right, so let's break this up and format the code a little bit. From to value, and then we'll just do this. This may be the best formatting, but we'll roll with it. All right, let's just do that. There we go. That's the transaction object. Okay, or the transaction hash, excuse me. All right, so that's an example of how to send ether between one account to another. So I will make a note that this is somewhat easy with Ganache because all the accounts are unlocked. So if you remember in previous sections, I talked about how you have to sign transactions whenever you're sending them on the blockchain. Well, there's some cases in which your account is unlocked and you don't have to do that. So if you're running your own Geth node, you can unlock your accounts. If you're running Ganache, these are automatically unlocked for you. If this was on a web interface like, when we were using MetaMask, from account, we'd have to be connected to our dApp, and we would have to sign this with MetaMask or something like that, okay? Or if you're going to do this just purely with JavaScript and no one to sign it, you have to sign it with the private key. So we'll get into that more in the Capstone project, but I want to just make a note of that here. All right, so that's an overview of how to use Web3.js. I would highly recommend that you get friendly with the documentation here. And also, if you want to get more practice on Web3.js in sort of a sandbox environment, I do have a long-form article on my website where I go through a lot of this stuff kind of step-by-step in detail. But like I said, we're going to go into a lot of the real-world application of Web3.js in the Capstone project. Fear not, you're going to get plenty of Web3 practice there. But if you just want extra practice, this is on my website for free. You can just go grab that. And also, I believe by the time the boot camp's out, I'll probably have a Python version of this as well. It's currently released on my YouTube channel. I don't know if the article will be available just yet, but that's definitely planning on coming soon. So if you want to learn how to use Web3 for Python, you're a Python developer, that should be coming soon as well. All right, so that's it. Now you know how to use Web3.js. Like I said, we're going to get plenty of practice with this in the capstone section. So check out the next video.